All right, today we're looking at similar triangles. Two triangles are considered similar if they have the same shape, but not necessarily the same size. Okay, so we have two properties that must be present in order for two triangles to be called similar. Number one, it says the corresponding angles of similar triangles are equal. Number two says the corresponding sides of similar triangles are proportional. So the angles have to be equal and the sides have to be proportional. You know, like in one triangle, each side may be half of the size of the other triangle. So they all need to be in proportion. It says if we wish to show that the two triangles are similar, we must show that one of the properties listed is valid. Okay? So only one needs to be valid. It says that if one is valid, then both are valid as well. So we're going to look at this example here. Example 10 says a right triangle with legs of 2 inches and 4 inches. It is congruent to another triangle with legs 2 and 4 inches. Okay, so here notice that you have the same measurement for the legs on a congruent triangle, and if the legs are the same, the exact same, then the angles have to be the exact same as well. So these are congruent. Whereas if you look at the second two, then here we have 4 inches, 10 inches, 2 inches, 5 inches. So it looks like they are proportional, because 2 over 4 is the same as 5 over 10. Both of those reduce to 1/2. So those are similar. Notice they're similar in that the sides are proportional, not the same. If the sides are the same, they are congruent. Okay, so here in example B, it says each triangle is equilateral. That means that here, equilateral, they have the same size, so it's congruent. Here, this is a similar triangle. You can noticeably tell that it's smaller than this one. Okay, so similar and congruent. And this next exercise, we want to assume that triangle ABC is similar. That little squiggly line denotes similar to triangle A prime, B prime, C prime, with angles A and A prime corresponding, B and B prime corresponding, and C prime corresponding. Find the indicated missing parts. So it is good to draw two similar triangles. A, B, C, A prime, B prime, C prime. So it tells us that the side AB is 5. The side A prime, B prime is 15. The side BC is 6. And they want us to find that side B prime, C prime. So we need to show that we're in proportion. So we can say 5 over 15. Notice we looked at, you can look at the corresponding sides of the similar triangle. So 5 over 15. And if we did the actual ABC triangle, then that's what you need to have in the numerator in both ratios. And this is equal to our little question mark. Okay, so, and you can call it x if you want to. If we solve this, we have 5. Let's call this our b prime c prime. Let's call it that. Question mark may be awkward for us. So when I cross multiply, I have 5 times b prime c prime equals 6 times 15. So b prime c prime is 6 times 15 divided by 5, which for us is 18. Okay, similar triangles. All right, so again, the directions said that we have similar triangles here. And in this triangle, A, B, C, A prime, B prime, C prime. It says if angle B is 30 degrees and angle A prime is 80 degrees, then they want us to find C prime. Well, remember that we had 2 properties that we could prove if 2 triangles were similar. That is, number 1, if their sides are in proportion, or number 2, if they have the same measure of the angles. So we know that there are 180 degrees in one triangle, and to find C prime, we subtract A prime, and B prime are going to be the exact same because we have similar triangles. So C prime is 180 minus 80 minus 30, which is 70 degrees. That's our C prime. All right. Let's look at these problems. It says, in these exercises, determine whether or not the triangles are similar or congruent. Similar or congruent, or neither. They may not be either similar or congruent. So let's look at these. Number 10, notice that if we flip this triangle around, this side equals this side. Those double lines here means that those double lines equal there. Okay, so if these 2 sides are equal, then it's gonna, be the case that the hypotenuse is equal as well. So this thing is congruent. Congruent, because if the sides are equal, then their angles are equal as well. Now, number 12 is similar. And let's talk about why. They tell us this angle is equal to this angle. This angle is equal to this angle, which means that this angle is going to have to equal to that angle. We don't know anything about if the sides are equal, but that's okay, or if the sides are equal or either in proportion, but we do know that those angles are equal, so that's similar. In order for us to be able to determine if that's congruent, we would need to know that the sides are equal as well. All right, so in these next exercises, we want to identify the corresponding angles and corresponding sides to the given angle and sides. It says the triangles are similar. So here it says angle S corresponds to what angle? Well, if we flip this around, okay, this is kind of like a slanted line. That's a slanted line. So angle S is corresponding to angle R. Side UT is kind of straight line. It's corresponding to this straight line here, which is side QP. QP. All right. Next couple examples, or the next example, I'm sorry. It says for the given sides of the triangles of figures 13.70 and 13.71, find the indicated sides. And we're looking at our problem, we're looking at 13.71, so this is what we need to be concerned with. We are concerned with that RP is 6, PQ is 8, RQ is 10, and ST is 9. Okay. So we need to find SU. Now, what they don't tell us and what they should tell us is that these are similar triangles. That needs to be known, that they're similar triangles. Because what we can do here is we can set it up. And if you notice, I don't know if you picked this up, but in the first example we did, we set up the two sides of one triangle equal the corresponding sides of the other. Then in one example we did, well, hey, the hypotenuse on one equals the hypotenuse on the other. You can set it up either way you want to, as long as you're consistent. In this example, we're going to say that SU, that's this side, over 10, this side corresponds to that side, equals, and we have to pick this 9 because that's the only thing we know here on the other portion that we know. 9 over, and that's a straight edge there, PQ, 9 over 8. We're finding SU, which is this diagonal. This diagonal here is 10, so SU over 10 equals the straight edge line here. That's 10 over 8. So what is SU? 8 times SU is 90. So SU is 90 over 8. And this one does not work out perfectly so that you can get a whole number back. You can get a decimal approximation for that, but that's what SU is. SU is the long side equals over the long side, the straight edge over the straight edge. Look at number 22. And number 22, it says BD is parallel to AE. AE is 18. DB is 6. If CA is 27, they want us to find CB. So here we can say this 18 over the short side of 6 equals 27 over this CB And we can solve for CB. 18 CB equals 27 times 6. So CB equals 27 times 6 over 18. So CB is 9. Alright, the next problem, it says solve for the unknown side by using an appropriate proportion. Parallel lines are marked with arrows. And our picture here is so we got a right triangle here. This is A, B, C. And then we come here and we have another triangle, D, B, E. And we have those arrows. So these two lines are parallel. DE and AC are parallel. It tells us BD is 5, BE is 8, and BA is 10. They want us to find BC. Okay, so let's set this up. 5 over this full amount of 10 equals 8 over that full amount of BC. So BC is 8 times 10 is 80 divided by 5. So BC is 16. Okay, now we're going to look at number 36. In this figure, 13.78, we have that triangle ABC. It's congruent to triangle ADC, which means the angles and sides are equal. So if we know that angle CAD is 40 degrees, they want to know how many degrees are in those two angles. CAB, which is this one, and A or CAB, which is this one, and ABC, which is this one. Well, because these triangles are equal or congruent, this angle corresponds with that angle. So we know that there are 180 degrees in a triangle, and if we subtract that 40 degrees, then we'll have 140 degrees, which is the number of degrees in the other two remaining angles. Okay. Number 38, it says, on level ground, an oak tree cast a shadow of 36 meters long. So we have an oak tree, it casts a shadow of 36 meters long. At the same time, a pole, let's draw this to scale because this pole, I'm sure, is smaller than that tree. A pole of 9 meters casts a shadow 12 meters. How high is the tree? So we want to know how high that tree is. We'll call it X. So we can set this up as 9 over 12 equals X over 36. So we have 12X equals 9 times 36, or X is 9 times 36 divided by 12. So X is 27 meters. That's how tall the tree is.